Hey badass coders, soon to be coders and engineer extraordinaires. In today's video, let's refactor our calculator function using the single responsibility principle. Some benefits are that it makes our code more modular and easier to understand, and it makes it easier to test and less prone to errors, among many other benefits. Let's jump right in. We created a very basic calculator in Python. We started by creating a function, and then we take input from the user, and we then perform operations based on the input from the user. So our function is actually handling several things at one time. A very important principle in programming is called the single responsibility principle, and it's part of a group of principles which are referred to as solid. So single responsibility principle is represented by the S in the acronym SOLID, and it's an important concept in software development that states that a class or a function should have one and only one reason to change, meaning a class or function should be responsible for one specific task and not multiple. So this helps make our code more maintainable and easier to understand. So in our calculator app, the calculator function is handling several responsibilities. Again, it's handling the input from the user up here, and then performing the calculation down here, and then printing the result. By adhering to single responsibility principle, or SRP, we can separate these responsibilities into different functions. So this way, if any one of those responsibilities needs to change, then only that particular function needs to be modified. So this makes the code more modular and less prone to errors, and easier to debug if we have to look for errors. So it also makes it easier to just test in general and understand the code as we look at it. So let's start the refactoring process. Let's create a new function, and we can declare that up here. We use the def keyword, and then we can name this, maybe get input. And so now we have a new function here. So this is the declaration of the function, and then we would call this function down here. So now we have our get input from the user, and then we can start refactoring out all the inputs. So we can start by just grabbing all this code from our input and then pasting it up here. And since we're using Python, make sure that you have your code tabbed in, since this relates to the scope of our function. So when our code is tabbed in like this, Python recognizes these lines of code, these 3 lines of code, as being inside of our function here. So we have a new function, and then we have our input code inside of our get input function. But now what? How do we get it out? So we know that this code works and it will take an input from the user, but we have to get it out somehow. So once it comes in, we can get it out by using the return keyword, and then we can return each of these variables. So we can return operation num1 and then num2. This will actually come out where the function is called, so down here. So this is where we are calling our function. So if we want to save that data that is returned out of it at the same point where it was called, then we can put this inside of a variable. So we could call this variable returned input. So now if we call this get input or run our code, I will actually comment our calculator out in general so that we can just test our get input function. And if we run this by typing in 2023 coding, hit enter, just enter a number here, 456, and then we can see that nothing happened here. And why is that? That's because we don't have any commands to do anything with the returned value. So what we want to do is take this return value and print it out. So we know that the data is saved in there, so now we need to print it so that we can see it in the console. So returned input. And then now when we run this, it will take our input, so we could just say the addition and the first number. It's not really going to matter what we input at this point. We just want to see that it's all returned. Okay, so we see that our input is returned, in fact. Before we move forward any further on refactoring our calculator code, I want to take a moment to look at the output that we received. So if you notice, we created a function called getInput, and then we are taking in our inputs and returning each of them as a variable. So if you scroll down here to where we called the function getInput, this is also where those values are returned. And so we capture those values returned by using the assignment operator here, the equal sign, and then on the left side, creating a variable name. So then all that is returned is captured inside of this variable name, and then we've printed this variable name contents to our console. So notice something interesting about the data down here. We have an open and close parenthesis with three different values and two types of data. So one of them is a string, which is our addition sign, and then we have two decimal data types here. So decimal just meaning there's a fractional component to it. It's not an integer. So like, what the heck? How is it possible that we have captured a collection of different data types down here? Well, I think this is a good time to break for a moment and just look at this type of data that we are moving. I'm going to create a new file over here, and we can just call this tuple.py. And I want to take a moment to talk about this type of data. A tuple in Python is considered a collection of elements, and it's immutable, meaning it cannot be changed after the values are declared within it. So it's similar to a list, but the elements in a tuple can't be modified once they're created. So tuples are defined using parentheses. So we can put in an open close parenthesis, and then the elements are separated by comments like we saw. So let's take our values that we have in the console down here, and we can just paste over this. And so you can see this contains two decimal values, and just know that tuples are commonly used to store related pieces of data. And so what is occurring here in our input data is that we are passing three separate variables out of here, or returning them out of that function, and all three of them are being placed inside of this variable named returned input. So you could consider that composing sort of a final collection of various types of information or data. So we've composed it, we've put it together, but now we need to pull it apart. We want to take each piece of that data and use it for something separate. So we call that process of unpacking decomposing. So we're going to decompose this tuple, and we can do that by assigning new variable names for each piece of data. As an example, we can name this operation, and then we separate each variable by a comma, and num2. And just so it's not confusing, you could actually name either of these variables something completely different than what we named them up here. They don't have to be the same thing because they are out of scope of this function now. We're unpacking them, we're using them for something completely different than what they were used for inside of the getInput function here. So just to show you, let's print operation just to make sure that we're getting it back. And then print num1 and print num2. And let's run this. And let's make our inputs. Do the multiplication. We could do 34 and then 72. And you can see we are receiving that input value back separately. They're being printed out separately right here. So just to show you that these variables don't need the same name as they did inside the function, we could call this division, just as an example. My number 1, another number. And then we could print each one of these out. Just to show you that these variables, when unpacking the tuple, can be named something different than they were inside of the function. And that's because, again, they are outside the scope of that function, okay? So you can see we have our values down here being printed out. So let's go back and rename these appropriately. Operator is appropriate because it clearly defines the type of data that's being passed through. We can go ahead and use num1 here and num2. And get rid of these print statements since we know that the data is passing correctly. Let's just look at a quick example of declaring a tuple and then unpacking it. So if we name this variable my tuple, and then we use the open and close parenthesis, we could create the number 2, a string that says cupcake, and then we can throw in another number here, a decimal, 3.14. So we've declared our tuple right here, and we'll comment this, declare tuple. And then down below, we can unpack our tuple. And we can unpack the tuple by creating the same number of variable names to match the count of values within our tuple. So for instance, we could simply write a number, food, a decimal. And then we can call our tuple. And then this allows us to basically feed in the values from the mytuple variable into each of these separate variables. So then we could do something with each of these values here. A number, food, a decimal, and then run this. We could run this. Right now we're running on our main file, but instead of switching that over, I will actually just place this here and run this. And then I will comment this out. You can just use command / to quickly comment out. And then we can see down here that we've printed out the values from our tuple. Also, since you have multiple values in a tuple, you may not want every value in a specific part of your code. So to treat some of those values as, say, like a throwaway, you can simply replace the variable name for that value with an underscore. So if we don't want the first number or the last number, we can just replace those variables with an underscore, and then we include a variable name for the value that we do want to return. So we will also try to print those just to see what it does. And we get the 2, the cupcake, and the 3.14, we get them printed. But also notice down here we're receiving errors. So if we actually wanted to use those values, we wouldn't be able to use them with that underscore. So it's just a way to throw the value away and basically say like, hey, I'm not using it in this place of my code. Okay, so now we can get back to our calculator. Let's get rid of our tuple examples, and then we can uncomment by using command / since I'm on a Mac. And if we scroll up here, we still have our function input, and then once again we are returning those outputs where we called the getInput function, and then we are decomposing them into separate variables here. Now that we have factored out the inputs using this single responsibility rule or principle, SRP, now we need to take those values and run them through our calculator. So what we could do is actually rename this, because we're going to create another function that is our calculator that brings all of these tasks together in one function. And since I have the conditional statement right here, I am actually going to rename this to calculate. And we need to be able to get these values returned from the get input into this function somehow. So one way that we can do that is by using parameters or input values up here as arguments inside of these open and close parentheses. This is sort of like a doorway for values to get passed into a function. So what we can do is use the operation variable there, num1 and num2, to pass them into our function so that they can be used in this conditional statement. So now we would have to call this function, this calculate function, down here as well. So below this get input, we could write our calculate function. And this is the call point. So remember up here, this is the declaration point. This is where we are saying what this function will do. So we're not actually using it at this point. We're just saying what it will do. So we're saying that this can take in an operation, a number, and then do something with it in here, okay? Down here is where we actually use that functionality. So what we want to do is down here, if we've got the operator and then the number1 and number2 returned down here, we have these values that we can do something with. So then we can actually use them by passing them in here and comma separating each one of them. So this can be a little confusing to look at first, because again, down here at the call point, we are actually moving data and doing something with it, whereas up here we're just saying what will be done with it. This is the plan. This is how we will deal with that data. Okay, so then now we've passed these values into calculate. So then up here we can see what is going to happen. The values are going to trickle in through this sort of doorway here as what we call arguments. They pass into the function. Something happens to them in here. We do some amount of work. And then if we wanted this to return a result, we could. So what we could say is, what if we wanted some value from here to come out of this function? Well, just like we saw in the first function, we could return. So we could simply just add the return keyword here and then get rid of these parentheses, because the return keyword doesn't need the parentheses. And then we can do the same here. So we're saying that once our values come into the calculate function, based off of whatever condition they meet, an operation is going to occur, and then we're going to return the result. And then we're going to return the result back down to the call point here. So what we saw earlier is we can capture that value by creating a new variable here, and we could just call this result. So now that final result is captured in here. And then we can print result just to confirm that our data is actually traveling as we expect it to. So let's go ahead and run this. And we add our addition operator. And let's just add 7 and 6. And sure enough, we do get 13 back in our printed result. We've done some pretty major refactoring with our very basic calculator here. To finish off this refactor, what we can do is actually put both of these calls to other functions inside of another function. So we're just nesting it. So they both have to be called anyway. So what we could do is we can use our def keyword here, calculator, just call this our calculator. And then we can tab in these code lines. You only need one tab there. We can actually use this as a comment for our call point, and then we can call calculator. Don't forget the initializer with the open and close parenthesis. So this is calling our calculator. Once this is called, the compiler comes in here and it looks at what needs to be done on this first line. It's going to call get input. So it comes up here to get input, and it comes inside and it looks at this first input. This sends the message to the console asking the user to input an operator. And then the next input is it asks for a first number and a second number, and then whatever the user enters is returned. And so then now that get input is done, we return a value at the call point, which was here. So the value comes through here and is decomposed from our tuple into 3 variables here. And then you can see these 3 variables are then called by another function right here, calculate, and they are passed in here to our calculate function. So if we come up to our calculate function, we can see that they come in, the values come in through here, okay, as arguments. We call them arguments, but you could just think of the parenthesis on the declaration of a function as a doorway, right? They come in through this doorway, and then we do something with them in here. So they meet all these conditional. So the values come in here and meet these conditional statements, whichever is appropriate. Those values then are returned. We save that result or that value to the result variable, then print this result to the console. So let's see if this all works. Let's give it a shot. So we can say minus, and we want to make our first number 4 minus 3, and we should get a value of 1 back. So perfect, it works. And then if you wanted to go ahead and refactor this further, if you look at this function, it is functioning as a calculator. This line is calculating, this line is calculating, and then spits out a result. But if you notice this line is doing something else other than calculating. It's presenting information. So it's printing a result. So we could create another function up here with the def keyword, and we could just say print result. And then we want to do something with this value, right? We want to pass it somewhere. So if we want to pass it somewhere, then we return it, but we need to pass it into our print result function. So what we could say is we can call print result and pass this variable inside of it, so we know that it's going to come up into the function itself. It's going to expect result, and then it's going to do something, which is print that result. So let's go ahead and run this one final time to make sure. We'll do some simple math so I don't confuse myself. We'll jump up there. Let's do a multiplication problem. Multiply. We'll keep the numbers small though. 3, enter, times 3. So we should get 9 back and print it to the console. So great job. Thanks for sticking around with me. This was refactoring, a very simple calculator that takes inputs from a user and then runs the inputs through some conditional statements and then calculates that problem to provide a result. And so what we did is we took that very basic calculator and we refactored it using a programming principle called the single responsibility principle, which is a part of an entire set of principles which are referred to as solid. So I hope you enjoyed this tutorial, and come back next time and we will continue to build out this calculator.